Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, this is part 3 video on the chapter of congruence, where I will discuss about the conditions of congruency between two triangles, the four conditions which are SSS, SAS, ASA and RHS. But before that, I will try to discuss about the combinations, various combinations of three matching parts, the matching parts and the matching pairs that are involved in the congruency of two triangles. To be very honest, I am very unsure whether I will be explain the congruency of triangles and all the four specific combinations properly or not. Even my notes, I don't know even my notes are written properly or not. I'm very uncertain regarding this video. This video will also get very long because I will try my best to explain the concepts, and in that process I may struggle, I may fumble. So please, if you are watching my videos regularly and if you somehow like my videos, please be patient, because I have to struggle a bit in explaining the concepts of congruency between triangles. So anyway, I will do my best. This video is part of the playlist CBSE Mathematics for class 7, following the textbook of author R.S. Aggarwal. And if you are new to my channel or not yet subscribed, I will strongly request and suggest that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. And if you have not watched the part 1 and part 2 videos on this chapter congruence, I would also like to request you and suggest you that you please watch them to maintain the continuity of your study on this chapter. So let's get started with this video. Okay, so I have even though I have prepared the rough notes for this video, that is understanding the congruency of two triangles and what are the conditions that ensure the congruency of two triangles. I don't know whether my notes are that you can follow my notes, or they are really up to the mark as far the concepts are concerned. But I did my best, so I will try to follow the notes. And also will try to explain based on my understanding. This chapter congruence, it's as far my understanding and experience is a bit complex, and for me it will be really hard to explain the concepts, even though I have understood the concepts myself, but it is a bit confusing and very little. It will be hard for me to explain. Anyway, let's get started. So on the right hand side I have the notes, and on the left hand side I have the notes, rough notes, and on the right hand side I will try to explain the notes and do whatever discussion and clarification of any concepts. So in the previous video I explained about correspondence between triangles. Now what is a correspondence between two triangles? When we establish a correspondence between two triangles, we basically map all the three vertices of one triangle with the three vertices of another triangle. So in this figure in the notes, we are having two triangles ABC and PQR. Now, so if there is we express the correspondence between two triangles with the double arrow mark symbol. So we say that when we say now in the notes you can see it is written a triangle ABC is having a correspondence with the triangle PQR. Now the ordering of the letters of both the triangle is very important. It is triangle ABC is mapped to triangle PQR. So this will mean that if you follow the letters in order, this indicates that vertex A is mapped to vertex P, vertex B is mapped to vertex Q, and vertex C is mapped to vertex R, and also it indicates that the side AB is mapped to side PQ, BC to QR, and CA to RP. Okay. Now, uh, point number 2 says that if you have a mapping between two triangles, a correspondence is established between two triangles. Let's say if you have triangle ABC is mapped is mapped to triangle PQR. This does not ensure this does not imply that triangle ABC is congruent to triangle PQC, because it may be the case by doing this. These are, I'm just recalling the correspondence concepts between triangles that I discussed in the previous video. I'm just recalling them. If we have ABC, if you have this, so this is a mapping. This says about a mapping between the triangle ABC and PQR in a very specific way. That is, A is mapped to P, vertex A, point A is mapped to point P, B to Q, and C to R. And this will automatically imply which sides of triangle ABC is mapped to which sides of triangle PQR. Now, this, by this symbol, I mean this does not imply, meaning from this you cannot say that triangle ABC is congruent to triangle PQR. This is super important, because just by establishing or expressing a mapping, we do not know whether because we don't know whether AB will be equal to PQ or not. We don't know whether BC is equal to QR or not. We don't know, and also whether CA is equal to RP. We don't know. So we can never say this expression, which is a mapping between the triangle ABC and PQR in a specific way, this is a correspondence. This is a specific correspondence. This does not imply that the triangle ABC will be congruent to triangle PQR based on this given correspondence, because the sides may be the sides may be unequal, the angles may be unequal. Okay. Point number 3. On the other hand, if we have if it is said that two triangles are congruent, let's say on the discussion part, I will take some other examples. I will not follow exactly what I've written in the notes. Let's say it is given that BSE, triangle BSE is congruent to triangle, let's say PRQ. This will definitely imply when so it is said that triangle BSE is congruent to triangle PRQ. This definitely implies the following things. First, the mapping is implied. Which is triangle BAC, that is a correspondence. This implies that triangle BAC is having a correspondence with triangle PRQ. Which means this indirectly implies that B is mapped to P, A is mapped to R, and C is mapped to Q. So first thing, if it is said that the two triangles are congruent under a specific correspondence, when we say this, we are automatically saying that the triangle BAC, we are automatically saying that under a given correspondence, which is this is the correspondence. Under this correspondence, the triangles are equal. Now under this correspondence, the triangle will be congruent when okay. So this is the first of all, when two triangles, when congruence of two triangles is given, is expressed, then it automatically implies the correspondence, which is this. Second, since they are congruent, the corresponding sides will be equal, the corresponding angles will be equal. So this automatically says that angle B is equal to angle P, angle A is equal to angle R, based on the correspondence. Angle C is equal to angle Q, and also AB will be equal to AB we have to be very careful and regarding naming the sides, which will be very specific, the way specific to the ordering of the letters in the name of the triangle we have used in expressing the congruency. So we will have BA equal to PR, we have AC equal to RQ, we have CB equal to QP. So basically we can also say that over here, so this is the equality of the sides and the angles, which is actually establishing, ensuring the congruency of the two triangles. Now over here in the first one, the automatic implication of the correspondence, this also basically implies that the side BA is mapped to side PR, the side AC is mapped, the side AC is mapped to side RQ, and CB is mapped to QP. Okay. So when we say this, the triangle BAC is congruent to triangle PRQ, what are the things that it automatically says or implies is, first, this one, the correspondence. It gives the complete correspondence details of the triangle between the two triangles, and also since they are congruent, the corresponding sides and the angles are also equal. Okay. Now point number four says that if based on these two triangles, in a triangle ABC, so let me also discuss point wise. So in triangle ABC, now when I am saying in triangle ABC and in triangle PQR, this naming actually does not matter, because ultimately what I am saying is there is a triangle. The first one is a triangle having vertices ABC, and the second one is a triangle having vertices PQR. Now in these two triangles, if it is given that A is having a correspondence with, say, P, this, sorry, what I am writing is P, this does not imply, you cannot say that only one correspondence between if you only know that vertex A in triangle A is mapped to some vertex in triangle PQR, then you cannot say about the total correspondence between the triangle ABC and PQR. So we have only mapped one vertex. So this is obvious. What I was trying to discuss was rather this: if you have 2 points, mapping of 2 points is given. Let's say A is mapped to P, and you also know that B is mapped to, let's say, R. B is mapped to R. This will automatically imply that the vertex C has to be mapped with Q. So basically, instead of writing this, I can also say that if I know in between two triangles some mapping is going on, and I know that A is mapped to P and B is mapped to R, or this, I can automatically say that the mapping established between the triangle ABC and PQR is this mapping. I know A is mapped to P, I know B is mapped to R, so C has to be mapped with Q. Okay. Now another thing, point 6, is that in triangle ABC and triangle PQR, if a mapping of one side is given, that is, the side AB of triangle ABC is mapped to the side, let's say QR of the triangle PQR, this will also automatically imply that A is mapped to Q and B is mapped to R, and we know that if we have two mappings of vertices, we have the entire mapping of the two triangles. So this will imply that triangle ABC is mapped to triangle A is mapped to Q, B, R. So this will be QRP. Okay. So this was I just wanted to discuss a little bit. This was a kind of preview discussion on the correspondence of two triangles, that how the vertices are mapped and what mapping of two triangles means. That it does not necessarily mean that they are congruent, and what are the minimum mappings between two triangles are required that will ensure the complete mapping between the two triangles. Mapping means you can also say correspondence. Okay, now let's start discussing about the congruence of triangles. Okay, congruence of triangles. Okay, now from the very first video, in the first part, we discussed that two plane figures are congruent when they are of same exact shape and size, that is, and which is verified using the method of superposing. That is, if you can place one figure on top of the other and they overlap perfectly, that is, one figure covers the other figures completely, then they are congruent. Similarly, two triangles will be congruent if they are having this same shape and size. Now in triangle, I could be wrong saying this, but I will. It is my intuition that so congruence of two plane figures are related to the similarity of shape and size. Now in triangles, so you know that in a triangle there are 6 parts, 3 angles and 3 sides. What are the parts in a triangle that determines its shape, and what are the parts that determines its size? I think that in a triangle, it is my understanding, I could be wrong, in a triangle, angles determines the shape and sides determine the size. It is my intuitive feeling, I could be wrong. Now, so two triangles will be congruent when the same principle follows, if you can superpose one triangle on top of the other so that one triangle covers or hides entirely the other triangle. Okay, now in the textbook, in words, how it is explained, it is said that two triangles are congruent if the corresponding angles and the corresponding sides are equal. Why? So why it is saying corresponding angles and the corresponding sides are equal? Whenever we discuss about congruency of two triangles, there are actually two aspects. The first aspect is that if we are trying to verify the congruency of two triangles, that whether two triangles are congruent or not, one aspect is that the correspondence is given. The correspondence is given, that is, the mapping of one vertices with the vertices of the other triangle is given, and now we have to just verify whether the angles are equal or not, whether the sides are equal or not. That is one aspect of dealing with problems of congruency of triangles. Another aspect is that you are given two triangles, no mapping is given. You are given two triangles, no mapping is given, no correspondence is given, and the measures of the two angles of the two triangles are given. Some measures of one triangle, maybe one angle, two sides, two side lengths, and similarly for other triangle, some measures are given, and from those measures you have to actually verify whether they are congruent or not, and in that process also establish the correspondence. Now the rules, you may have already completed this chapter, this congruence, and you might already be knowing about the SSS, SAS, SA, ASA and RHS congruence conditions. Now remember that these four congruence conditions are based on a given correspondence. That is, okay, before going on to those four conditions, so in the congruence of triangles, in the notes, if you see, the point number 1 says congruence of two triangles is verified under a given correspondence. You are given two triangle ABC and triangle PQR, and you have to verify whether these two triangles are congruent or not. Now definitely we will not do method of superposing and verify that way. That is not possible. We have to mathematically prove. That is by proving that that all the three angles of one triangle is equal to some corresponding angles of the other triangle, and all the three sides of triangle ABC is equal to some corresponding sides of triangle PQR. Now, when it is about verifying the congruency, if it is about verifying that triangle, whether triangle ABC is congruent to triangle PQR or not, it is asking you that under the it is basically asking you under the correspondence is indirectly implied, or it is already automatically given, which is it is asking you that using this correspondence you now prove that they are congruent. That is, the three angles of triangle ABC are equal to the corresponding three angles of the triangle PQR. Three sides of triangle ABC are equal to the corresponding three sides of angle PQR, because you know the correspondence. This is about verifying the congruency of two triangles. When you are asked to verify some congruency of two triangles, now this thing is also known as congruency name, I guess. This is the name of congruency. Okay, so this is congruence relation, or congruence name. This is termed as congruence relation or congruence name. This thing, that triangle ABC is congruent to triangle PQR. Now, so if you change the order of the letters of the triangle ABC here, or change the order of the letters of the triangle PQR, the congruence relation will change, or the congruence name will change. Now, if you are given the congruence relation or congruence name, and if you are asked to verify whether it is true or not, then what you have to do is, you know the correspondence, and then you just prove that the corresponding sides are equal and the corresponding angles are equal. Okay. So this is what the first point is saying. Congruence of two triangles is verified under a given correspondence. When you are asked to verify the congruency of two triangles, please note that the correspondence is also given. Now, what is point number 2 saying? From given measures of angles and side lengths of two triangles, congruence between them can be established. Okay. So the second aspect of problem solving regarding congruence of two triangles is that you are not given any correspondence. You are just given triangle ABC. Possibly they are congruent, or I mean, not possibly, they are, of course, will be congruent, say PQR. And what you will be given is that some measures will be given. Let's say this is 2 centimeter. Let's say this is 2 centimeter, and let's say this is 3 centimeter. This is 3 centimeter. This is 4. This is, let's say, this is 1.5 centimeter, and this is 1.5 centimeter. So some measures are given, or some angles may also be given. Let's say this is 30 degree and this is 30 degree. From these measures, you have to somehow prove or express the prove that these two triangles are congruency, and in that process you also have to name, you also have to provide the congruence relation. That is how they are mapped, that is the mapping, and also that based on that mapping, the corresponding, once you have the mapping, you know the corresponding angles, you know the corresponding sides, then you have to prove the corresponding angles are equal and the corresponding sides are equal. So this is another aspect of problem solving regarding congruence of triangles. You are given two triangles, figures will be given, and you will be given the measures, some measures of triangle ABC and some measures of triangle PQR, and you will be asked to prove that they are congruent. And also you will be asked what is if they are at all congruent. If they are congruent, then what is the congruence relation, or what is the congruent name? That is whether it is you are if you have established the, if you have proved that they are congruent, whether it is like this, triangle ABC is congruent to triangle PQR, or it is that BCA is equal to is congruent to triangle QRP, whatever. You have to name these congruence. You have to tell the congruence relation. So this is another aspect of problem solving on congruency. Point number 3 is that I think so if it is given that two triangles are congruent, so let's say if triangle ABC is congruent to triangle PQR, then you automatically know the mapping. That is, it will automatically imply that triangle ABC is having a correspondence with triangle PQR, which eventually means that A is mapped to vertex A is mapped to vertex P, vertex B is mapped to vertex Q, and vertex C is mapped to vertex R. So that this is number 1, that you get information when it is said, given that triangle ABC is congruent to triangle PQR. What else information you know? You will know that angle A will be equal to angle P, and the three corresponding angles will be equal. That is point number 2. Point number 3 is the corresponding sides, the length of the corresponding sides will be equal. Now in the 2 you see it is written that corresponding angles are of equal measures. Fine. So these corresponding angles are also known as three pairs of matching parts. You know that in a triangle, regarding congruence, I have a triangle ABC. Now I will try to verify whether this triangle is congruent with another triangle, whatever triangle it is. May be congruent, may not be congruent. Now we know that the basic things, these are the very fundamental things. So we have in verifying congruency of two triangles, each triangle has six matching parts. 3 are angles. So 6, I already discussed about this in the previous videos. 6 matching parts. This triangle we also have 6 matching parts. The triangle ABC, what are the 6 matching parts? The 3 angles and the 3 sides, AB, BC and CA. For the triangle PQR, the 6 parts are the 3 angles, angle P, Q, the 3 matching parts actually, and also the sides, the sides PQ, QR and RP. So these are the 3, so we have 3 matching parts which are angles and 3 matching parts which are sides for a triangle, in a triangle related to congruency of two triangles. Okay. Now what else? This was point number 3. This is all points and concepts I am discussing related to congruence of two triangles. Point number 4 is that uh, in two triangles, if you are given two triangles are given, two figures are given, and it is said that the length of the side AB is equal to the length of the side PR. Also, it is said that the length of the side BC is equal to the length of the side QR, and the length of the side AC is equal to the length of the side PQ. If you know that in two triangles, if you know that that the three sides, if you have this information that the length of three sides of triangle ABC is equal to is equal to some corresponding sides of the triangle PQR, then also the congruency is established. We can say in this example, if AB is equal to PR and BC equals to QR and AC equals to PQ, if you observe properly and try to map the vertices, you will see that we will have the result triangle ABC is congruent to triangle PRQ, not PQR but PRQ. Okay. So point number 5 says that three angles and three sides are the 6 matching parts of congruence of two triangles, which means that when we discuss about congruence of two triangles, we ultimately match. What do? We ultimately match. We ultimately compare the three angles of one triangle with the three angles of the other triangle, and we match, and we compare the lengths of the three sides of one triangle with the length of the three sides of the other triangle. So when I say comparing, it also means that we are trying to match. So three sides and three angles are the 6 matching parts of congruence of two triangles. This essentially means that when I will try to verify that whether a triangle is congruent to another triangle, I need to match the three angles of the triangle and the three sides of the triangle to the respective or corresponding angles and sides of another triangle. Okay. Now, so we know that if two triangles are congruent, so one thing is sure, that we have understood, if we have, let's say, triangle ABC is congruent to triangle PQR. So when we say this, we are also automatically implying that the correspondence, that is, we are trying to verify that the sides and angles, corresponding sides and angles are equal under the mapping, under the correspondence or mapping this PQR. If this is true, we know that this will automatically imply that angle A will be equal to angle P, angle B will be angle Q, angle C will be equal to angle R. Also, AB will be equal to PQ, BC will be equal to QR. That is, the length of the corresponding sides will be equal. So CA is equal to RP. You see that six matchings are happening. This is a matching. This is a matching pair. That is a matching pair. What is a matching pair? A matching pair is nothing but one part of triangle, one part of one triangle and another part of another triangle. Now, when we in the congruence of triangles, definitely we match an angle of one triangle with the angle of another triangle, and also one side of a triangle with the side of another triangle. We never match an angle with a side or a side with an angle. So a matching pair. So these are the matching pairs in this congruency. These are the matching pairs. So there are 6 matching pairs. In this matching pair, in this matching pair, the parts are angle A of triangle ABC and the angle P of triangle PQR. In this matching pair, the parts are what is a matching pair? A matching pair is a pair of parts of two triangles. So the first in the pair, the first part is the side AB of triangle ABC, and the second part, the second part of this matching pair is the side PQ of triangle PQR. So we are having 6 matching pairs, which is finally establishing, which is basically, you can say, a result. If we say the triangle ABC is congruent to triangle PQR, it will ensure these 6 matching pairs. Now think it in a reverse way. Do we need all these 6 matching pairs to prove that triangle ABC is congruent to triangle PQR? So in the notes I have a question. To ensure congruence of 2 triangles, is it necessary to verify equality of all 6 pairs of matching parts? 6 pairs of matching parts. By this I meant all these matching parts. That is, we have 3 pairs of matching parts involving angles and 3 pairs of matching parts involving sides. If we have to verify that triangle ABC is congruent to triangle PQR, do we have to ensure or see that all these 6 pairs of matching parts are true? The answer is, do we have to prove all these 6 results, that is, angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, AB is equal to PQ, BC is equal to QR, and CA equals to RP. So we have 6, over here we have 6 pairs of matching parts with equality. That is, in each pair the parts are equal. In each pair the parts are equal. That is, if it's a matching pair of angles, if it's the matching pair of angles, then the 2 angles should be equal. That is, one angle is from triangle ABC and the other angle is from triangle PQR. Do we need to prove that 6 pairs of matching parts with equality? The answer is no. And after a lot of study, it has been found that it requires only 3 pairs of matching parts of specific combination to prove the congruency of 2 triangles. 3 pairs of matching parts of specific combination. Now, this sentence says a lot of things, and it is really very hard to really explain what exactly it is meant. So what it is saying: 3 pairs of matching parts of specific combination. Forget about the specific combination for the moment. 3 pairs of matching parts. 3 pairs of matching parts. Okay. So we know that matching pair. What is a matching pair? Something like this. Let's say. So it is saying that we will need 3 pairs of matching parts. Okay. So I have 3 pairs of matching part. This is a matching pair. This is a matching pair, and this is a matching pair. Now, what can a matching pair be? A matching pair. Now, this is where I will really struggle in explaining the concepts. What are the types of matching pair? It can be either you are either matching one angle of one triangle to another angle of the second triangle, or one side of triangle. Let's discuss with respect to the triangles ABC and PQR. So a matching pair could be, a matching pair is either you are matching a side with a side, or an angle with an angle, right? We match and we verify the equality of 2 angles, and we match, or either we match or try to compare 2 angles, or we match or try to compare 2 sides. So a matching pair, its type can be either side-side, that is, the left hand side will be a side from the triangle ABC and the right hand side will be a side from the triangle PQR, So, or it could be of angle. Now, so we need three pairs of matching parts. First pair, second pair, and third pair. Now consider, just think, what can the first matching pair be? It can either be of type side or it can be of angle. Angle. Also, the second matching pair will also be either side or it can be angle. And also the third matching pair, it will be either a side or angle. So, so the possibility of this matching pair could be of type either, I'm abbreviating side as S and angle as A. It could be of type angle or side. Similarly, this matching pair could be of type angle, side. Similarly, this matching pair could also can be of type angle, side. Now, if you give a little bit of thinking, that each matching pair is either a pair of type angle or it is a pair of type side, you will notice you will notice uh, you will notice a pattern between the three parts. Now, three parts that you are considering in a triangle in determining the congruency of the two triangles. Now it has been found that you need three pairs of matching parts, and these are the matching parts 1, 2, and 3. So by circles I mean a part, a matching part of a triangle. So all these are matching parts of triangle ABC, and all these circles are matching parts. It is the matching parts of triangle PQR. Now, so you can see that in these three pairs of matching, parts, as I already discussed, each pair is either a angle or angle matching, or it's a side matching. Now, if you give a little bit of thought, you will understand that basically all the three pairs of matching parts can be categorized into the following category, can be divided into the following category. Let's say categories. If I say categories of three pairs of matching parts. Categories of three pairs of matching parts. Now, it is said that you need three pairs of matching parts to ensure the congruence between two triangles. So, you will see that either when we are considering how do we select those three pairs of matching parts, what eventually all the possibilities when we are trying to see, there will be many possible ways of selecting three matching parts from a triangle. I can take three sides, I can take three angles, I can take one angle, two sides, I can take okay, let's say I have this triangle ABC, I have this triangle ABC. So I know that I have this triangle PQR. I am trying to, in the process of finding whether they are congruent or not, I know that I need three pairs of matching parts. And what is a pair of matching parts? That is, I have to choose three parts from triangle ABC, and three parts from triangle PQR, which I will match and compare. Now, in choosing three parts from triangle ABC, I can choose I can choose let's say I can choose I can choose all the three sides. I can choose three sides, or I can choose three angles, or I can choose two sides, one angle, or I can choose two angles, one side. So when you are trying to select three parts from triangle ABC, which you will match or compare with the corresponding three parts of triangle PQR, you will see or find that eventually you are either selecting selecting the three parts of triangle ABC, either the three parts are all three sides, or they are all three angles, or there are two sides, one angle, or two angles and one side. Okay. Now, in the notes, you can see that all possible combinations of three matching parts of a triangle. So it says that when we have to select three matching parts from a triangle, what are the possible ways we select the three matching parts? It could be all three sides, and if you take all the three sides, the only possibility is that one, because we are eventually selecting the three sides, we don't have any other choice. So the number of choices is one, that is, we are selecting the three sides. And when all the three sides when all the three matching parts are sides, we call it as SSS, that is three sides. Now, when all the three matching parts are angles, they are all angles, then also we are having only one choice. There are three angles in a triangle, so there are no other choice. We are choosing all the three angles. So that choice is, a name is given, which is AAA, that is three angles. Now, if we are selecting in the three matching parts, in selecting the three matching parts, if two matching parts are sides, we are selecting two sides and one angle, then there are many possibilities. We can select, as you can see in the notes, regarding the triangle ABC, I can select side AB, side BC, and the angle B. This is known as SAS. Why? Because I am selecting two sides, AB and BC, and the angle included between them, that is angle B. Now I can also choose side A, side B, side AB, side BC, and any other two angles, that is A and C. Similarly, I can also choose angle side BC and side CA, and any other angle. If I choose the angle C, it will be of particular importance because the angle C is the including angle between the side BC and AC. So there are many other possibilities, as you can see in the notes. If in the selected three matching parts, two are sides and one is angle. Similarly, if there can be in the three matching parts, two can be angles and one can be side. So there are 9 possibilities, and also in two sides and one angle there are 9 possibilities. Now in the two angles and one side, the first possibility is that I choose angle A, I choose angle B, and I choose the side which is included between the angle A and B, which is side AB. This is of special importance. This pattern or combination is known as ASA. There is angle side angle. That is the middle side. The S is in between two A, which means that this S is the included side between the two angles. Okay, so these are, as you can see, three sides, three angles. When I am selecting three matching parts from a triangle, then what are the possibilities in doing the selection of three matching parts? So these are the possibilities. Either I select all three sides, or I select all three angles, or I select two sides and one angle, in which case there will be 9 possibilities, or I select two angles and one side, in which case there will also be 9 possibilities. Now so there are so many possibilities. Is there a way that any specific combination of all these possibilities will ensure the congruency of two triangles? The answer is yes, and this is where we come to the discussion of congruence conditions between two triangles. So it says that 4 specific combination of 3 pairs of matching parts ensures the congruency of two triangles. So if I consider the triangles that we are discussing the congruency about, let the triangles be ABC and PQR. So we will discuss now the congruence condition, which are basically 4 specific combination of 3 pairs of matching parts. So we have SSS, we have SAS, we have ASA, and we have finally RHS. So let's understand what is, and we will discuss this related to the triangles which we have named triangles ABC and PQR. So what does SSS congruence condition says? It says that, so as per the SSS congruence condition, the triangle ABC and triangle PQR will be congruent if 3 sides of the triangle ABC are equal to the corresponding 3 sides of triangle PQR. There has to be some correspondence between the two triangles, based on which the congruency will be verified or established. So it is saying that, basically it says that if the 3 sides of the triangle ABC are equal to some corresponding sides or to the given corresponding sides of the triangle PQR, then they are congruent. So as you can see in the diagram, in this specific diagram, I have assumed that the side AB is equal to PQ, AC is equal to RQ, and BC is equal to PR. So in this case, as per this diagram, I can say that triangle ABC is congruent to triangle QPR. Okay, so I have given two examples where the three where we know that the 3 sides of triangle ABC is equal to some corresponding sides of triangle PQR, and based on that correspondence we can establish, or we can say about the congruency of the two triangles and the congruency relation. That is the ordering in the congruency, the ordering of the letters ABC or PQR. So this was SAS congruence condition. That is, if 3 sides of one triangle, if you prove or if you verify that 3 sides of one triangle is equal to some corresponding is equal to the 3 sides of three corresponding sides of the other triangle PQR, then they are congruent. The next is SAS congruence condition, side angle side. So what does it say? It says that two sides and their including angle of triangle ABC, I mean the triangle ABC and triangle PQR will be congruent if two sides and their including angle of triangle ABC are equal to the two corresponding sides and their including angle of triangle PQR. So in the figure, as you can see in this figure, the triangle ABC and PQR, we have that the side AB is equal to side PQ, the side BC is equal to side QR, and the included angle of side AB and BC, which is angle B, is equal to the corresponding included angle between the side PQ and QR, that is Q. B is equal to Q. If we have this, then we can say that triangle ABC is congruent to triangle PQR. Now, please note one thing very carefully. If in this figure, in related to this figure, I am not drawing the figure. If it is given, if we have that the AB is equal to PQ, and it is given also that BC is equal to QR, but it is given that angle B is not equal to angle Q but angle R. This is not a SAS congruency condition. This is not a SAS congruency condition because angle B is the angle included between the sides AB and BC, which is fine, but angle R is not the included angle between the sides PQ and QR. So this is not a condition, SAS condition. You have to be very clear about this. So when you are proving that two sides and their included angle is equal to of the triangle ABC is equal to some corresponding sides of the triangle PQR, then the angle also has to be in triangle PQR also has to be the angle included between the two corresponding sides. So as another example, you can see that if you have this in the triangle ABC, AC is equal to QR and BC is equal to QP, and the included angles are equal, that is C is equal to angle Q, then we will have the relation, we will have the congruence relation, triangle ABC is congruent to triangle RPQ. Now one question might be, you might be asking one question that how, let's say for the SSS case, how from the SAS, all these conditions, that is SAS or SSS or conditions, how we are knowing the congruence relation or the congruence name. So for the SSS condition, you see that in the first figure, it is given, if we have in the first figure we are having AB is equal to PR, and we are having AC is equal to PQ and BC is equal to RQ. The question is, from this, how do we know the congruence relation? How do we express the congruence relation? Okay, so it is given that AB is equal to PR. Now AB is equal to PR means it is saying that the length of the side AB is equal to the length of the side PR, the length of the side AC is equal to the length of the side PQ, and the length of the side BC is equal to the length of the side RQ. Now how do we know the mapping? Which vertex in triangle ABC is mapped to which vertex in triangle PQR? Okay, now you have this. Let's consider these two. AB is is given that AB is equal to PR and AC is equal to PQ. Now from this you see that a common letter in the two sides of the triangle ABC is A. I am considering that I will consider two equality at a time. Let's say I am considering that AB is equal to PR and AC is equal to PQ. I see in the two sides of the triangle ABC, in AB and AC, the common letter is A, and also the corresponding common letter in the triangle PQR is P. So this will ensure that A has been mapped to point P. Vertex A has been mapped to vertex P. Similarly, if you take these two, you will see that the common letter in the sides AC and BC is C, and so C, and the common letter in the sides PQ and RQ is Q. So you immediately know that C has been mapped, vertex C has been mapped to vertex Q. Now when you know the two vertices, the mapping of two vertices, automatically you know the mapping of the third vertex, which is B, which should be R. Now you see, now you check that triangle ABC is mapped to triangle ABC. Why it is QPR? It should be C is mapped to Q. Now if we have this will imply that triangle ABC is having a correspondence with triangle PRQ, but in the notes I have written QPR. Why is it so? Let me check. AB is equal to PR, AC is equal to PQ, and BC is equal to RQ. AB is equal to PQ, BC is equal to PR. Definitely B has to be mapped with P. Okay, and also AC is equal to RQ, not AC, but in the notes AC is equal to PQ. No. In the diagram it is given wrong. In the notes you can see below the diagram I've written AB equals to PR, AB is equals to PR, AB is equals to PR. No, that is wrong. AB is equal to PQ. Anyway, so as per the diagram in the first figure, I will have, it is given that you know that the equality of angles and sides in two triangles are mentioned with for sides it is mentioned with a small dash or double dash or triple dash. So if triangle ABC, we have a triangle ABC and we have a triangle PQR. I hope you are aware of this, but still I will just recall. So if I want to say visually, graphically in the figure, if I want to say that side AB is equal to side PQ, I will give a single dash on the side AB and a single dash in the side PQ. Now if I want to say that side BC is equal to side QR, I will use a double dash because single dash has already been used. I will use a double dash, also double dash in QR. So this means that AB is equal to PQ and QR is equal to BC, and if at all AC is equal to PR, I will use a triple dash. So this way the number of dash will increase. In a triangle it can be only 3 sides, so three dashes are used. So as per the figure, in the notes, it is actually what is given is AB is equal to PQ, AB is equal to PQ, AC is equal to RQ, and BC is equal to PR. Now you see, if I take these two, I see what are the common points. For the triangle ABC, for in sides AB and AC, the common point is A, and in the sides PQ and RQ, the common side is Q. So we know that the mapping is there is a mapping between A and Q. If you take these two, we just need the two mappings of two vertices. Then the mapping of third vertex will be automatically implied. Now from AC equals to RQ and BC equals to PR, we know the common points in the sides AC and BC is C, and the common points between RQ and PR is R. So we know there is a mapping between the vertex C and R, and so obviously then the vertex B has to map with P. Now let's see. So we have triangle ABC is mapped to triangle QPR. So hence you see that it is implying the congruency of triangle ABC is congruent to triangle QPR. So this is about when you have the three sides equal, how do you establish the congruence relation or congruence name. Now let us see how do we do this in terms of for the SAS congruence condition. So let's say in this figure, in the notes, please follow the notes. In this first figure, we have AB equals to PQ. So two sides are equal and the included angles are equal. Now in this, from SAS congruence condition, the one mapping you can immediately infer is the angle. In this figure, it is given that angle B SAS, it is given that angle B is equal to angle Q. This will automatically imply that B has to map with Q. I need another mapping. Okay, now see the two sides. We have AB equal to PQ and we have BC equal to QR. Now I will use the same logic that I used in SSS congruence to determine the mapping of two vertices. If I see these two equality, we have the common point of sides AB and BC is B, and the common point of the two sides PQ and QR is Q. So, B and Q is already given. Why? No, this is not helping. B is mapped to Q is already given from the angle. We already know. No. Now, how do we know the mapping of vertices A and C? This is the question. Okay. Now, okay. So the thing is, you know that AB is equal to PQ. I know that B is mapped to Q, and it is also given that AB is equal to PQ. In this AB equals to PQ, I see if I leave B, I know B is mapped to Q. So automatically I will know that A is mapped. Since B is mapped to Q, we already know from the angle that angle B is equal to angle Q. Under SAS congruence condition, the two angles, the two equal angles will also imply the mapping of the two vertices, which are as per the angle names, letters. So we know in this example, we know that angle B is equal to angle Q. This automatically implies that B has been mapped to Q. If we know this, and we also know that AB is equal to PQ, and we know that mapping between B and Q. So we know the mapping, that there is a mapping between A and P. this and B, the fact B is mapped to Q and the fact that AB is equal to PQ will imply A is mapped to P. So once I know B and Q, mapping between B and Q, mapping between A and P, I automatically know, I can say that C is mapped to R. So the congruence relation becomes ABC is mapped to A is mapped to P, B is mapped to Q, PQ, R. So this is the way you can find the congruence relation or the congruence name from SAS congruence condition, that is the two sides of one triangle, two sides and its included angle of one triangle is equal to the corresponding two sides and their included angle in the other triangle. Okay, this was SAS congruence condition. Third one is ASA congruence condition. Two angles one side, two angles one side. So as you can see, all these four, the first condition was SSS, that is three sides. The second was SAS, that is two sides and one angle. The third is ASA, two angles on one side. So this says that the triangles ABC and PQR will be congruent if two angles and their including side of a triangle ABC are equal to the corresponding two angles and their including side of triangle PQR. So you can follow the notes and you can verify. I have given two examples. Now let's try to. So what is in a triangle? In a triangle, what is two angles and their including side? So if let's consider the triangle ABC. Triangle ABC. If I consider the sides AB and BC, if I consider the sides AB and B, if I consider, sorry, it is about two angles on one side. Okay, two angles on one side. So if I consider any side, let's say AB, the two angles included by the side AB is basically the angles A and B, which you can obviously know from the letters of the side AB. So side AB includes angles A and angle B. Similarly, side BC includes angle B and angle C. Similarly, side CA includes angles. This is just to give you what is a side and the included angles. Okay, now about the ASA congruence. So AS congruence. Now let's say I have a triangle ABC, and I'm trying to verify that I know that, and I'm trying to apply the ASA congruence condition in these two triangles ABC and PQR, to verify their congruency or congruence, and I'm considering the side AB of triangle ABC, and I know that it's the corresponding side of side AB is the side, let's say PQ in triangle PQR. So I know that the corresponding side, that PQ is the corresponding side of the side AB in triangle ABC. Now if I want to apply the ASA congruence rule, I know the angle included, the angles included by the side AB is R, angle A and angle B. So I automatically know that, I also know that the angles included between the side PQ will be P and Q. Okay, so if in these two triangles I have AB equals to PQ and angle A is equal to angle P and angle B is equal to angle Q, I can say that these two triangles are congruent, that is, and the congruence relation will be ABC will be congruent to triangle. Now you see that when you know that angle A is equal to angle P and angle B is equal to angle Q. From these two facts, you automatically know the mapping, that is A is mapped to P and B is mapped to Q. So this will imply that C has to be mapped with R. So you know the mapping, so I can name the congruence relation, that is ABC will be congruent to triangle PQR. Okay, so in this figure, if it was given, if let's say if BC is equal to, given, we know or we have found that if BC is equal to QR and we know that angle B is equal to angle R and angle C is equal to angle Q. So this will imply that the congruence relation will be, you know, since it is given angle B is equal to angle R, we know that B is mapped to R, and C is equal to angle C is equal to angle Q, we know that the vertex C is mapped to vertex Q. So this has to be, so then A has to map with P. So P R Q. So this is the way when you are applying the ASA congruence conditions, and you know that you know the which side of triangle ABC and its included angle you are corresponding to which side of the triangle PQR and the included angles. From that information you can easily find the congruence relation or the name of the congruence, that is, this is the congruence relation or the naming of the congruence. Now I hope it is clear that in the SAS congruence condition, it is saying that two sides and their included angle of triangle ABC. Now of course it can be the two sides and their included angle, the two sides can be any two sides of the triangle ABC, and the angle has to be the angle included between those two sides. And similarly, when you are the corresponding sides and the corresponding sides and their included angle in triangle PQR could also be any corresponding sides and their included angle. Similarly, in ASA congruence condition also, when you are considering a side and their included angles, it could be any side in triangle ABC and their included angles, and of course the corresponding side in triangle PQR and the angle between those corresponding sides. So this was ASA congruence condition. The last one is RHS congruence condition. Now this is specific to right angle triangles, meaning if you know that the two triangles are right angle triangle, then you can apply this condition to verify that these two right angle triangles are congruent. The condition is that hypotenuse and one arm of triangle ABC is equal to the hypotenuse and corresponding arm leg of triangle PQR. So you have two triangles which are both right angle triangle. The RHS congruence condition works for two is applied between two right angle triangles. So I have a right angle triangle ABC. I have another right angle triangle PQR. Now these two triangles will be verified to be congruent. I know that one angle is the angle, and let's say in triangle ABC, B is right angled, and in triangle PQR, angle Q is right angled. So I know that one angle is equal, angle B is equal to angle Q, I know. So what else information in RHS do I need to verify to ensure that these two triangles are congruent? The hypotenuse must be equal. Now in the triangle ABC, since it is right angled at angle B, I know the hypotenuse is AC. Also in triangle PQR, since I've assumed that it is right angled at angle Q, I know the hypotenuse is PR. The hypotenuse is PR. What else do I need? Now the third information that I need is that one arm of triangle ABC, one arm or leg, you know that the sides in a right angle triangle other than the hypotenuse are known as the arms or legs. So in triangle ABC, if it is found that one arm of triangle ABC is equal to some arm in triangle PQR, then these two triangles will be congruent. That is, if AC is equal to PR, that is AC is the hypotenuse of triangle ABC and PR is the hypotenuse of the triangle PR. So if they are equal, and let's say the arm AB of triangle ABC is equal to the arm PQ of triangle PQR, this will imply, and of course we know that they are right angle, that the triangles are right angled, and we know that angle B is equal to angle Q is equal to 90 degree. Now this will imply that triangle ABC is congruent to triangle PQR. Now how come I know that it will be PQR and not PRQ or something else? Because from the right angles, that is B is right angle, Q is right angle, I know that B is equal to Q is equal to 90 degree. This will imply that B is mapped to Q. Okay. Now from the sides, check the sides AC. Now that I know that AC is equal to PR. Sorry, not AC. AC is equal to PR is the hypotenuse. Sorry. Also I know that AB, the one arm of triangle ABC is equal to some arm in triangle PQR, which in this case I have assumed that AB is equal to PQ. From this I will know the mapping of I will know, this will imply that A is mapped to P. Why? Because I know B is mapped to Q. So in AB equals to PQ, it has to be the case, since B is mapped to Q, so A should map with P. So now we have got that A is mapped to P, B is mapped to Q, and C is mapped to R. Now B is mapped to Q we already know, because we have assumed that the triangles are right angled at angle B and Q. Using that information and the information that AB is equal to PQ, we have found that A is mapped to P. Automatically we will know that C has to map with R. So this will imply that triangle ABC has to be congruent to triangle P, Q and R. Now let's take another example of this RHS congruence. Let's say I have this ABC, this triangle, let's say not this one, this is becoming the same as the previous one. Let's take some different example. Let's say I have this is triangle ABC. This triangle ABC is right angled at C, let's say, and of course definitely the hypotenuse will be AB, and the triangle PQR, let's say it is something like this. PQR. Of course, this is right angled and this is hypotenuse. And let's say the arm, let's say the arm BC of triangle ABC is equal to the arm QR of triangle PQR. So what is given? We know that since the triangle, we know that the triangle ABC is right angled at QC and also the triangle PQR is right angled at Q, we will have angle C is equal to angle Q equals to 90 degree. First information we have this. And we also know that the hypotenuse of the two triangles are equal. So we will have AB equal to PR. Now one arm, let's say the arm BC of triangle ABC is equal to the arm QR of the triangle PQR. Now from this, of course, this will ensure the two triangles are congruent because we are having both are right angle triangles. The hypotenuses, the length of the hypotenuse are same, and also one arm of the triangle ABC is equal to one arm of triangle PQR. Now from this, how do we know the congruence relation or the name of the congruence? Okay, so let's say triangle ABC, we have to name find the congruence relation. What will be this? Okay, now let's try to find out the mappings. From the mappings of the vertices, we can say the mapping of the two triangles, that is the correspondence of the two triangles. Now since angle C is equal to angle Q, angle C is equal to angle Q will imply that C is mapped to Q. Okay. Now from the fact that you can consider the arm which are equal, so BC is equal to QR. BC is equal to QR. Now in this we know that C is already mapped to Q, so it has to be case that B has to map with R. So this and C is mapped to Q will imply that B is mapped to R. So we have A, so we have now A will automatically map to, we know the mapping of B and C of the vertices B and C in triangle A. So we can know automatically the mapping of vertex A, which will be P, So we are having this, A is mapped to P, B is mapped to R, and C is mapped to Q. So this implies the mapping ABC, as PRQ. Now so this is the mapping, and since these two triangles are congruent based on the RHS congruence condition, so we can say that triangle ABC is congruent to triangle, this is the congruence relation or congruence name, PRQ, based on this figure. Okay, so one more point is that if AAA, that is three angles, if three angles of one triangle, if three angles of triangle ABC are equal to any corresponding three angles of the triangle PQR, then it does not necessarily ensure the congruency between the two triangles AB and C. So you can see that in the example in the notes, I have triangle ABC and triangle PQR, where we know that angle B is equal to angle Q, angle A is equal to angle P, and angle C is equal to angle R. With this information, only this information, it will not necessarily mean that the triangles ABC and PQ are congruent, because as you can see clearly, the triangle PQR is of larger size, and two triangles are congruent only when their shape and size are equal. Clearly we can see the sides of the triangle PQR are of larger size. So just equality of three angles between two triangles does not ensure a congruence. This you must keep in mind. So this was all about basically the congruence of two triangles and what are the four conditions of that ensure the congruence between two triangles, that is SSS, SAS, ASA and RHS. I will not solve any problems. I will not solve any problems because already the video has is already very long. So if you are watching this video so far, I really appreciate it. And in the next video, I will solve the problems, the exercise problems from the textbook of author R.S. Aggarwal. So I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will do problem solving. I will start with the exercise problems from the textbook of author R.S. Aggarwal, and then I will prepare some practice test problems which you can solve. Try to solve yourself first, and if you are stuck, then only you can see my solution videos. So until the next video, take care and bye.